Hello everyone, welcome to One Stop Study Classes. Today we'll discuss about the second chapter of class 11th Maths ncert, Relations and Functions. In the last class we discussed about sets. Relations and functions is an extension of that chapter. That means the knowledge of set is the prerequisite that you require to understand this chapter of relations and functions. In the last chapter, we discussed what are sets. In this chapter, we'll go forward with that information, go a little forward with that information, and understand what kind of relations can you form between two sets, and which type of relations are called functions. Which means to understand functions, you should first understand relations, and functions is a subset of relations. Certain relations will be called functions. All functions are relations, but all relations are not functions. To understand relations, you further need two more basic concepts. One, what do you mean by ordered pair? And second, what do you mean by Cartesian product? Both requires the knowledge of sets. Relation in general mathematics, could be relations between any pair of variables or any pair of quantities. Let's consider in terms of numbers, 1 is less than 2. Here you're forming a relation between two numbers 1 and 2. You can also write the same using variables. M is less than n. 2m plus 4 is less than 3n. It's a relation, an inequality formed. P is parallel to Q. A relation is formed between two quantities. Here, an expression, two expressions, a relation between two expressions based on certain two variables. Now, if you consider this m less than n or m is parallel to n, p is parallel to q, you understand that you require at least a minimum of two quantities to form a relation between them. And a specific sequence is to be followed. You cannot write n less than m. These two will not be equal or may not be equal. P is parallel to Q. It means that Q is also parallel to P. But this may not always be true. If you change the value, if you change this parallel value. So what do you mean by ordered pair? Pair, if you understand, is two quantities. You require two quantities. Which are these two quantities? So let's understand the statement with the help of an example. Let us consider P and Q as two sets. P contains three elements, A, B, and C, and Q contains two elements, 1 and 2. An ordered pair could be a relation, a way of writing the two elements, one from each set. So a pair of elements, that means ordered pair means it is a pair of elements from different sets from P and Q. If you're talking about a pair, you'll have to take one element from P and one element from Q, written in a small round bracket. So let's draw the round brackets and grouped together in a particular order. So let us take one element from P and one element from Q. Or let us take one element from Q and one element from P. So these are ordered pairs, a sequence, a pattern. First element and then second element. First element and then second element. Now, let's understand what is Cartesian product. Now, Cartesian product makes use of these ordered pairs of elements. So, if you have, again, two sets P and Q, and P, we took an example for it, A, B, and C, but we can also represent it in terms of variables. Let us consider small p belongs to capital P. This small p means it is a variable given to objects of P, variable given to the elements of P. P can hold any of the values as A, B, or C. Similarly, small q belongs to Q. Small q is a variable given to any elements of the set Q. So Q is equals to 1 or Q is equals to 2. Moving on. So what do you mean by Cartesian product? Product, as we know, is represented by cross. Cartesian product, here you are taking the product of these two sets P and Q. So either you can write P cross Q or you can write Q cross P. Since it makes use of ordered pairs, both the values of these two Cartesian products will be different. Let's calculate the values and then define them in theoretical form. We are trying to calculate the value of P cross Q, and P cross Q means Cartesian product of P and Q. P is a set and Q is a set. P cross Q is also a set. So it will be the elements of P cross Q will be in curly braces. Now P cross Q means the ordered pairs. Cartesian product means the ordered pairs from P to Q. From P to Q means the first value in an ordered pair will always belong to P. Let's consider A. And second value is Q. Any value from Q. In first scenario, let's consider 1. And in second scenario, let's consider 2. This leads you to two ordered pairs, first and second. Which other ordered pairs can be formed? Over here, P cross Q means first P's element. Let's consider the second element of P as small b, comma 1, small b, comma 2. Again, C, comma 1 and C, comma 2. So what do we have here? Cartesian product of two sets P cross Q is a set of ordered pairs from P to Q. We are able to form 6 such ordered pairs. So there are 6 elements of P cross Q. Let's calculate the value of Q cross P. Q cross P is equals to, again it is a set of ordered pairs of sets. But first you'll mention Q's element. So Q's element is 1. Then you'll mention any of the elements from P. At the second position, 1, comma B, 1, comma C, 2, comma A, 2, comma B, 2, comma C. Observe every ordered pair, which is represented in round bracket, is separated from every other ordered pair by a comma. Similarly, within the ordered pair, the two elements are separated by another comma. The placement of such commas should be precise. So as you can see, this 1 cross A, this element will never be equal to this element. Why? Because for two elements to be equal, two ordered pairs to be equal, let's say A1, comma B1 is one ordered pair and A2, comma B2 is another ordered pair. So for two ordered pairs to be equal, their corresponding first elements should be equal and their corresponding second elements should also be equal. So even if we have A, comma 1 and 1, comma A in two Cartesian products, P cross Q and Q cross P, the two values are not equal, they are different. Similarly, this value will be different from this value. In short, no element of P cross Q is present in Q cross P and vice versa. They have different elements. That's why P cross Q is not equals to Q cross P. They are different sets. Now, let us define this. For any two sets, P and Q, if you take the Cartesian product P cross Q, then this set will be equal to set of all the ordered pairs P cross Q such that P belongs to P and small q belongs to Q. This is how you define it. We represented P cross Q with a set of ordered pairs P comma Q. P stands for the first element, which is P, and Q stands for the second element, which is Q. Ordered pairs over here can also be generalized as P comma Q, where small p belongs to capital P and small q belongs to capital Q. But this is just a notation. It's not a set. It's a way of representing elements of set. Ordered pair is a way of representing elements of set, and Cartesian product is where you represent all the elements, all the combinations you can form from between two sets. So all the relations can be represented in a Cartesian product. But we will study about relations in the next class. Right now, let's study about certain properties of ordered pair to understand them better so that you do not make any mistakes with elements of Cartesian products. So properties of ordered pairs, we understood that how they are equal. They are equal only when the first element of one ordered pair is equal to the first element of another ordered pair, and the second element of one of the first ordered pair is equal to the second element of the second ordered pair. That means A1 should be equal to A2 and B1 should be equal to B2. For these two should be to be equal. For these two to be equal, it's compulsory, it's necessary that these two conditions is satisfied and vice versa. This is double implies. The symbol of double implies we studied in sets. It means that if the left hand side is true, then right hand side is true. And double implies means if the right hand side is true, then the left hand side of double implies is also true. Next property is, it's more of a condition. If you have the number of elements in P and you have the number of elements in Q, or you're representing it by A and B. If you have the number of elements in A and number of elements in set B, then you can calculate the number of elements in the Cartesian products of A and B. It's simply the multiplication of these two values, A and Q. For example, here, number of elements in P was 3. A, B, and C, 3 elements. Number of elements in Q was 2. So, number of elements in P cross Q is equals to 3 into 2, which is 6. Similarly, Q cross P, here also, number of elements in Q cross P is equals to 2 into 3, which is equals to 6. So if you know the number of elements of two sets, you can easily calculate what is P cross Q. What is the number of elements in the Cartesian product of the two sets, irrespective of the order. Even if you calculate for number of elements of, even if you calculate for the number of elements for B cross A, you'll still end up with Q into E. And in maths, we know that PQ is equals to Q. So 2 into 3 will be equal to 3 into 2. Next property. If you have two non-empty sets, that means non-empty sets means number of elements of A is not equals to 0 and number of elements in B is not equals to 0. Or the same thing can also be represented as A is not equals to 5 and B is not equals to 5. Or in words you can write A and B are non-empty sets. So if you have this condition that you have two sets which are non-empty sets, and if either of the two sets is infinite in nature. So, for example, A is an infinite set and B is a finite set. It is not supposed to have 5. A is an infinite set and B is a finite set, then A cross B will be an infinite set. So will B cross A. It is all B cross A will also be infinite set. If A is equals to 5 or B is equals to 5 or both are equals to 5, then A cross B will be equal to 5 and B cross A will also be equal to 5. That means, for example, if A is equals to 1, 2, 2 elements, and B is equals to no elements, 5, or no elements in A and B, in the set B, then there wouldn't be any ordered pair which would be formed over here, because for ordered pair you require 2 values. Even if you write the first value, there is nothing in the second value, so you cannot form an ordered pair. Hence you cannot have any elements in A cross B or B cross A. Next. Now ordered pairs means 2 quantities, but we know that we can also form relations between different variables, more than 2 variables. Let's say you have P less than Q less than R. Here a relation was formed between 3 variables, 3 quantities, or P plus Q plus R is equals to 1. A relation is formed between 3 quantities. We require all the elements from these quantities to form a relation. So when you have 3 quantities, then you call them ordered triplets. We won't go further than triplets because that would be difficult to handle, and we'll know that why after a while. I'll explain that. Anyways, so ordered triplets, you can write, say, A cross B cross C. You're taking Cartesian product of 3 sets A, B, and C is equals to, in ordered pair, you write them small a, small b, small c. I'm considering small a to be all the elements of A, a variable representing elements of A. Small b, variable represents set B. Small c, a variable representing all the elements of set C. This is ordered triplets, where A, B, and C, this in round bracket, is an example of ordered triplets. By default, the sequence matters. Capital A, small a, capital B, small b, capital C, small c. The sequence matters. If you change the sequence, your answer would be incorrect and your ordered pair would be incorrect. Either way. Now, what happens if you consider real values? Say, R is a set of real numbers. This is what we know. So real numbers are all the positive, not just positive, all the numbers that can be represented on a number line. This is this is another way of defining a set of real numbers. All the numbers that can be represented on a number line is capital R. So what would a Cartesian product of R and R represent? What would be the what would you call this Cartesian product? What is the meaning of this Cartesian product? This small r, this capital R, a set of real numbers, represents all the points on the number line. So, if you consider this is also a set of A comma B, of A comma A, where A belongs to R Now A can have any value of the number line. Logically speaking, this is all the points on your graph paper. For example, 1, 2, 3, 4, -1, 5, etc. There are infinite combinations. A is a real value. So all the points on a graph paper, or you can call this as coordinates of all the points in two-dimensional space. Similarly, R cross R cross R will form an ordered triplet These are coordinates of all the points in three-dimensional space. I hope this much is understood. In the next class, we'll discuss about relations, and further in the third class, we'll discuss about functions. Thank you so much.